Hello, another day, another nostalgic math chat. IEB November 2023, paper 1, question 8. Right, 3 parts to this question. Let's look at the first one. In the diagram below, we have f of x is equal to 12 over x for x greater than 0. Okay, so that's a hyperbola, and the domain has been restricted. We're just looking at the graph where x is greater than 0. Then G is the axis of symmetry for f. Okay, so because this is a hyperbola that hasn't been shifted up or down, that means that its axis of symmetry are going to be the same as for the basic hyperbola, for this hyperbola, right? And the axis of symmetry, axes of symmetry, y is equal to x and y is equal to negative x. And we can see that our graph has a positive gradient, so it can't be this guy. It would have to be this one. Okay. Right. So we'll just make a note of that here. Or rather, let's say. Okay. B is the point where F intersects G. Okay. H is the tangent to F at point C, and A is the y-intercept of H. Okay, so we have 3 graphs, 3 functions that we're dealing with here. Let's see what we need to do first. Write down the equation of G. Okay, so easy mark. We've already spoken about why that is G of x is equal to x. Let me actually open up the memo just so I can check myself now and again. Okay, almost there, almost there. Okay. Yes, so nice one mark there. Yeah, in agreement. Right, then, okay, so same story where we now know that this is g of x is equal to x. Determine the coordinates of B, so of this little fellow over here. The intersection of f of x is equal to 12 over x and g of x is equal to x. Okay, so points of intersection, we know how to figure that out. We're looking for the value of x where the output of f is equal to the output of g, or the y coordinate of f. Yeah, that doesn't make sense. We're looking for the value of x where the y coordinate is going to be the same for both functions. Okay, so let's see. 12 over x is equal to x. You can then times both sides by x. So that would be 12 is equal to x squared. A nice quadratic function, quadratic equation. So this could be positive or negative, hypothetically. But we know that we're only considering f of x where x is greater than 0. So x can't be negative. So x is then equal to positive 12. So we now know that the x coordinate is 12. Now to figure out the y coordinate, we can say, well, what does the function output when x is 12? And that is indeed 1. And of course, if you just double check with g, right? Whatever x is, y is in that function. So, tricky. No, that we can't gloss over that. We got different answers. What is happening? Okay, let me just really put my mind into this. Oh, hectic. Oh, that's stupid. Okay, so the answer is not plus or minus 12. Oh my goodness. How do you feel just watching me walk into these mud pies? Right, so that would be 12 over root 12, which is root 12. Yeah, if it is not evident from the tone of my voice, today is not a good day for me. But I wanted to record, so here we are. Right, so now we have the same y for both functions. Okay, cool. Another good reason to just always double check your answers. So the coordinates of B are x is equal to 12. No, man. Oh, I wish I could just snap out of the funk. Snap out of the funk. Right, root 12 and root 12. Hopefully not too confusing. If it is, let me know. I will re-record when life is better. Okay, so we have g of x is equal to x. We know that f of x is equal to 12 over x, and b is root 12 and root 12. Okay, so the last part of this question asks us to determine the area of ACO, okay, so triangle. If h of x is negative a third x plus c. So this is h of x is equal to negative a third x plus c. Okay. So what we need in order to calculate the area of a triangle is the length of one base and the perpendicular height to that base. I know we're not meant to rely on the diagrams too much to make decisions about things, but I am just going to lean on it a little bit in order to figure out which base would work best. CO looks slanted, so does AC, whereas AO is a vertical line, so the length of that will probably be easier to figure out than this guy. Well, that's debatable actually. That is debatable. We could really, it might not be hard at all. But then where does the perpendicular height even go? Would it be something like this? Yeah, figuring that out I think would be actually the tricky part. Whereas if we use this as our base, then the perpendicular height is also then a horizontal line. So if I can figure out what the coordinates of C are, and I can figure out what the coordinates of A are, then my work is pretty much done. So let's see. So we want to know what the coordinates of C are, which is tricky because we don't know what the plus C is here. And therefore, and if we can figure out what the plus C is, then we have the coordinates of A, which would be good. So how can we figure that out? So what we know about H is that it is a tangent. It is a tangent to this hyperbola. So we need to figure out, okay, at what point in this hyperbola do we have a gradient of negative a third? So let's do that. So we know that f of x is equal to negative, is 12 over x, which is the same as 12x to the negative 1. So the first derivative is negative 12x to the negative 2. So now we're asking ourselves, where is the gradient equal to negative a third? That's the question we're trying to answer. So we say negative 12x to the negative 2, we need that to equal to negative a third. And we need to figure out where it's equal to negative a third. Okay, I think I need to move. I don't know if I'm going to be able to, but one can try, one can try. There is really no harm in trying. Perfect. Okay, so I just need to move that. And actually rotate it if I can. Oh! That is for, how do I rotate? Ah, nice. Okay, so I'm going to move that over here. Just let it hover somewhere awkwardly. Right, okay. So we were busy solving this. Just gonna try, okay, let me actually write this out as a fraction again, because then it gives me a good idea of how to solve it. Okay, you can do the dreaded cross multiplication. Very important for you to know what this means. Okay, if you don't know why it works, find out. Okay, so the negative could either belong to this guy or this guy, and likewise on the other side. For the sake of convenience, I am going to give the negative to the top guy over here and to the bottom guy over here. So that would be positive 36. So positive 36 is equal to x squared, right? And so we can take the square root on both sides. So again, we have to consider the positive and the negative possibility. So x could be plus or minus 6. But again, we are only dealing with the portion of the hyperbola where x is greater than 0. So because C is a point on that graph, x must be greater than 0. So actually x is equal to positive 6. Okay, so far we know that C has an x coordinate of 6. So when x is equal to 6, the gradient at that point of the hyperbola is negative a third, right? And we know this because the tangent at that point has a gradient of negative a third. Okay, and we also need the y coordinate, do we? Well, okay, we need the point in full so that we can figure out the equation of the tangent, so that we can figure out what the coordinates of A are. Okay, so we know that the x coordinate of C is 6. That's what we know so far. Okay, I want to shrink some things. Okay, so now to find the y coordinate, so the y coordinate of C is going to be whatever the function f evaluates to when x is equal to 6, which is 12 over 6, which is 2. So the y coordinate is 2, right? So therefore C has the coordinate 6 and 2. Okay, so now on the one hand that gives us the length of the perpendicular height, which is, because we know that this is x is equal to 6, so this would be 6 units, eh? Okay, so now we just need to figure out what the coordinates of A are, which means we need to figure out what the equation hx is in 4. So, to figure out C, sub in C into h, right, the function h. So, we know that h of x is equal to negative a third x plus c. So we know that the output of the function is 2 when the input of the function is 6. Okay, so now let's solve. Oh my gosh. So we have 2 is equal to negative 2 plus c. So that's 2 plus 2 is equal to c. So c is equal to 4. So in 4, h of x is equal to negative a third x plus 4. And this is the y-intercept, which we're told a is. So that means that a has coordinates 0, 4. Okay, so let's just write that. So a has coordinates 0, 4. Okay, so let me shrink that also real quick. Yeah. Okay, so now we can figure out that OA is 4 units long and perpendicular height to OAO is 6 units. And so the area of the triangle OAC is half base times perpendicular height, which is half of 24, which is 12 square units. Right, that is a big one. But yes, she is in agreement with us. Everything is awesome. Okie dokie.